purely on pure mathematics. So all the questions are pure mathematics lah. Then for paper 2, it's the same format for H1 paper 1, which is split into pure maths and probability and stats. Okay, so for H2 math and history math, the format for H2 math is similar to H2 math, where it's 2 papers of 3 hours long and it's 100 marks each. The first paper is purely on pure mathematics, and then paper 2 is also split into pure maths and probability and stats. However, for H2 for the math, it's split into the paper 2 is split 50-50 instead of 40-60 in H2 math. So for history math, for the A levels, it's also one paper. It's only one paper, so it looks simple, but it's only one paper, and it's also just 3 hours and 100
早就
marks.
开始了，那期。
Oh, sorry, whoever that is, can you mute the mic? Thank you. Yeah, so history math is sweet and simple, one paper long exam. It's only 3 hours long. So if you can do the math for my subject combination, for someone like me who took H2 math, H2 for the math and history for the history math, I have spent 15 hours sitting in the exam hall for A levels just doing purely maths lah. So you can see it's kind of I would say a cheat code for the A levels where you're doing basically the same subject over and over for all your papers lah. So and you don't need to, how to say, okay, don't take this the wrong way, but you're kind of studying lesser in a sense, where if you study for these kind of subjects, you're reinforcing your strengths and your weaknesses for the other counterparts. So let's say I study for H2 for the math, I'm kind of studying for H2 math at the same time, and this is unique to this kind of math subjects in JC. So an additional point for H2 for the math in JC, right? It'll be a content subject along with your H2 math. Whereas for the history math, you can only, so what I mean by content subject is you'll be taking it for 2 years in J1 and J2, and then you'll be taking it for the A levels. Whereas for history math, for MOE subject where it's not a research paper, not a university history subject, you only take this history math in J2, and it's an additional subject to study for in J2. So it won't replace any of your content subjects in J2 and for the A levels, but it's an additional thing lah. Also, if you have noticed previously, the title for the previous slide was H21 math, H21 math, H1 math versus H2 math. And the reason for this is because in JC, let's say for a subject like math, right, it has H1 and H2 counterparts. You can only take either one of the two. So you can only take H1 math or H2 math. And it's the same for other subjects like physics and economics. For my next slide, I'll be talking about the syllabus of the various subjects in JC lah. So this should answer your questions about what is taught in JC math and how will it compare to secondary school math. Also, you guys, if you have questions along the way, you can join the Menti room. The code is 17187671. Okay, so moving on. So this is the syllabus for H1 math. It's pretty short and sweet. To give some more background information about H1 math, right? It's designed in a way such that it's actually meant for people who didn't take A math in secondary school. So coming from my friends in JC who took H1 math, right? They told me that the pure math portion, which is basically point 1 and point 2 on the slide, covers at most, if not lesser than the A math syllabus. So the only thing that will be new to you are the items that are bolded, which is like binomial distribution, normal distribution, all these kind of things you probably would not have seen or encountered before in secondary school. For H2 math, it's a pretty big jump in terms of content from H1 math and A math, especially for the pure maths portion, which is points 1 to 5. So we have things like functions and graphs, sequences and series, vectors, complex numbers, and calculus. So in most schools, they actually require you to have taken A math for O levels in order to take H2 math in JC. I remember for my JC, for those who didn't take A math and wanted to take H2 math in JC, they had to take a placement test or rather a diagnostic test to see whether or not they are ready for to take H2 math in JC even though they didn't take A math lah. So even even so if they did pass the test, they will still need to go for bridging lessons because um it A math is basically assumed knowledge once you come to JC lah if you take H2 math. So they go for these lessons to cover up the gaps in their learning so that they are prepared and ready to take H2 math in JC. So in H2 math uh you learn new things that you didn't see in secondary school lah. So basically uh talking about vectors, right? You will learn to handle 3D vectors instead of and also and, okay, you learn 3D vectors and you rarely see 2D vectors in JC already. So I remember touching base on 2D vectors, 2D vectors back in secondary school. And personally, I find it more fun to learn 3D vectors since we live in a three dimensional world, right? So another cool new thing that you will learn is complex numbers. You probably have never heard of this in secondary school, or probably have never even seen it in secondary school. I remember the first time I saw complex numbers, I was like, wow, what is this thing that I'm seeing right now? So you probably would have heard in secondary school by teachers that if you square root a negative number, you'll be an error or something like that. And then if you see it in your working, you're kind of like, that's not good. But in JC or in H2 math, you will learn how to manipulate this kind of square root of negative numbers or square root of negative numbers, which can be manipulated in a place called the complex realm lah. So you learn about imaginary numbers, which is basically a square root of negative one, and how to do basic operations such as addition, subtraction, division, and multiplication with this imaginary numbers. So of course in H2 math, actually a rather large portion of the subject is on calculus, which is differentiation and integration. And of course, you will learn something new called differential equations and the Maclaurin series. So I put an asterisk beside the integration techniques for H2 math because it's also present in H1 math. However, it's limited to the techniques that you learn in secondary school. However, in H2 math, there will be new techniques that you learn lah, and it really goes way beyond what you learn in secondary school. And then at the same time, it's really assumed that you know your A math content you know your A math content down very well lah, in order to handle the kind of integration questions that you will see in H2 math. Then of course for statistics and probability for H2 math, there's an additional subtopic called discrete random variables compared to H1 math. Also, if you have noticed, there's also this last topic called correlation and linear regression. It's for the past 2 years, it's been a common last topic lah. As also for H2 math. So um, I'm not very familiar with it, but I remember it's kind of like similar to drawing the graph for AMF. Is it AMF or EMF? The one where you plot out the graph on the graph paper and all that. Yes, it's called linear law. Yeah, so I'm getting a message from my friend. He'll be touching more about linear law for you guys later on for his presentation. So don't worry, so you can learn more about that later. So now for further math. Okay, so for further math, it's often called an extension of H2 math, or at least that's how I see the subject as lah. So I mentioned for A math, it's assumed knowledge for H2 math. But then for H2 further math, it's kind of the same thing, but then it's H2 math is the assumed knowledge for H2 further math. Okay, but this is not in the sense that if you want to take H2, if you want to take further math in JC, right, you will need to know the whole H2 math syllabus beforehand. It's just that in some topics for H2 math, you learn more things for that topic in further math. So an example of this would be for complex numbers, which I talked about just now. In H2 math, you would have learned how to do the basic operations for complex numbers, which is addition, subtraction, multiplication, and division, and of course something called uh, conjugates and all that. However, in H2 math, you need to be very good at all this because you need to manipulate these skills in order to solve higher order questions that are usually present in H2 for the math lah. So of course there are also topics that you would not find in H2 math in but then you'll find them in further math. So these topics include like mathematical induction, conics. It's a pretty big portion of the H2 further math syllabus. Matrices and linear spaces. So if I recall correctly, I learned how to do basic operations on 3x3 matrices in secondary school lah. But um, we didn't really learn why were we doing that or what was the purpose of learning matrices in the first place. However, in H2 for the math, you will learn something called linear algebra, where you'll be manipulating these kind of matrices in order to solve questions lah. And also for so the points 1 to 8 are the pure math portions for further math, and then the remaining topics are the probability and statistics portions for further math. So um in H2 math, there's a subtopic called discrete random variables. However, for H2 for the math, there's additional things for this topic, which is these two things called Poisson and geometric distribution. Then along with that, there's continuous random variables, which um comparing discrete and continuous in the name. Discrete is basically things that you can count, like um objects are like one stick or one pencil, two pencils, three pencils. For continuous random variables, it deals with things like time and distance. Then for there's also hypothesis testing in H2 math and further math. However, you will learn additional kinds of tests for further math. Instead of the only test that's learned in H2 math is something called the z-test, which makes use of normal distribution. So in further math, you will learn additional tests like the t-test and this is called a chi-squared test. It's not x-squared test. So also there's this last topic called non-parametric tests, which has been CLT for the past 2 years or so. So I'm not very familiar with it. So for further math, so something similar to what I mentioned just now about how those who didn't take A math in secondary school needs to take a kind of a diagnostic test or a selection test in order to take H2 math in JC. In most schools, if not all, right, you need to take a placement test for further math during like the first few days in JC during like orientation and all that. So along with this test, which I will talk about a bit later, there's also like requirements lah for your secondary school subjects in order to be even considered for the test in the first place. So for my school ASR, the requirement was to have A1 in both E-math and A-math in order to take the test. So I remember on the first day of JC where I did I knew nothing about JC, I knew nothing about further math. I suddenly saw there was a sign that says there'll be a test for this subject called further math later in the afternoon. And then I was like, oh, sounds interesting. Maybe I will stay back for the test and do it. So I remember staying back for the test, and if I remember the questions correctly, it really stretched. So it was all solvable by AMF techniques. However, the thinking and the thought process I needed to put in was stretched really, really uh really hard compared to what I was familiar with in secondary school. So I remember only being able to do like maybe half of the six questions that were in the test. However, I still managed to they still offered me the subject lah. So I guess they saw the teacher saw that I was capable of applying like the thought process that's needed to survive in these kind of higher level subjects lah. So okay, so lastly for the highest order math subject in JC is history math. I took this screenshot directly from the syllabus. So kind of weird thing about history math right is if you go and look at the syllabus document for the other subjects, you see that the content part of of the document will probably be like 4 pages long with all these um sub notes about what will exactly be tested for A levels. However, for history math, the content syllabus portion of the document is basically like 1 page long or even lesser than that, and then they it's they basically tell you that you will learn about these kind of things, inequalities, which is higher level inequalities that are used in like in proofs that are usually published by like professors and all that in university. And then you learn about something called number theory, where so usually in day-to-day life you will learn about how to use these numbers, how to use results and all this. But then in history math you learn kind of like the history of the numbers, I would say, and how numbers interact with one another, which is kind of useless in day-to-day life, but the results are pretty nice and interesting lah. Then um in okay, all three subjects, H1 math, H2 math, and H2 further math, there's a topic called permutation and combination, which is kind of like the kind of questions where they ask you, oh, how many ways are there to arrange like these three objects and all that. This is also present in history math, but you will learn um high level techniques to solve like even crazier questions lah. So I can say about history math. So it may look kind of innocent where this is the only thing that the only thing that will be tested for history math. However, they have this kind of footnote at the bottom which says students will also prove results and solve problems outside these defined areas or at the intersection of two or more or such areas using the ability to understand and apply given definitions or results. So what that means is basically they can give you like um kind of a quick introduction of this technique or result in the paper itself, in the A-level paper itself, and they expect you to learn that thing on the spot and make use of it immediately to solve questions. So this is the kind of um, level of thinking that's required uh, for a subject like history math, and it's also similar to the way they would ask questions would be similar for other history subjects like history physics or history chemistry and all that. So now I'll show you um, what questions usually look like for the A levels. So okay, so this question it came out for this year's H2 Math paper 1. So you can see that um you can actually um solve this question without any H2 Math knowledge at all. It's basically just asking you to sketch this graph y equals modulus x squared minus 5 and y equals 2x minus 1, and then so there's just graph sketching or just drawing a graph, and then they ask you to find the exact solutions of um of these two equations lah. And you really don't need any um um prior H2 math knowledge to solve these kind of questions. So but okay, this is just one example of what can come out lah. So this next question is about complex numbers, and you definitely need H2 math content to solve this kind of question lah. So it may look intimidating all that, but once you actually come to JC and learn um how to tackle these kind of questions with the knowledge that you have that you will learn, you will see that it's actually not that bad. So you can see like how the mark allocation for A levels works lah. So sketching of the two graphs, you draw one graph is 1 mark, the other graph is another mark. So that's done. And then the solutions, the working is probably 2 marks. The bulk of the working is probably 2 marks, and then you can expect 1 mark for the for the solutions lah, or 1 mark each for the solutions. So this H2 math. So this next question is from H2. Oh sorry, there's a typo in the slide. This from H2 for the math, and this question is about conics. So if you remember way earlier in the presentation, I mentioned how E-math is focused on problems in real world context, and whereas A-math is focused on pure mathematics, just purely doing the calculations, all that. However, in H2 math and especially in H2 for the math, uh, it's kind of you can expect questions to be a mixture of both lah. So you can be expected to use pure math knowledge to and then apply it to a real world context. So in this question, it's about the elliptical orbits of planets lah, or sorry, of a moon around Mars, and then conics is considered a pure math topic in for the math. So they'll ask you questions like prove this result, or and then find the area of the orbit of the moon around Mars using integration, and then an example of they give you like a result or theory in the paper itself, and then they expect you to make use of it immediately in the paper. So this part of the Kepler's second law of planetary motion. We didn't learn this explicitly in during lessons. However, my teacher did briefly mention something about this, and then it came out for my paper lah. So these are the kind of questions you can expect to see in further math, and of course H2 math as well lah. But conics, this level of conics is not in H2 math. It's only found in further math. Okay, so this was my year's H3 math, one of the questions in the H3 math paper. So you can see that the mark allocation is kind of insane lah. So like I said, each question is in H2 math, H2 for the math, H3 math, or even H1 math, right? One question can go up to, in this case, 12 marks. I've seen questions go up to like 13 and 14 marks before. So you can see the kind of thinking that you probably would need to put in order to solve these kind of questions lah. So for this for the first part, most of you probably would be able to do it. It's just you can see that if you can recognize patterns easily, it's just replacing x with 1 over x, and then you will arrive at the given result already. And then for the second part, it's just a matter of getting rid of the one of f1 over x in order to isolate the fx term. And then for part B, you'll be kind of wondering how does one even start these kind of questions. So actually, it's kind of like for JC math, right? It's kind of like once you've done enough questions, or once you understand the exact reasoning as to why you do things in each step, right? You would kind of pick up techniques on how to start to solve questions lah. In history math, we had a lecture on problem solving, and basically what I learned was the process of problem solving lah. So there's like different processes involved in problem solving, which include like trial and error and working backwards, all these kind of techniques. You would pick up along the way as you over the 2 years in JC where you do more and more math lah, basically. So I prepared a solution for this question. So for the first part, you can see it's just a matter of replacing the x with 1 over x term in the function. And then the second part for part A is just isolating the 1 over x term, and then substituting it into the original equation to isolate the fx term lah. And then for part B, it's kind of just this method that I found and did in the A-level paper was basically just me trying to replace all the terms with the different other terms found in the equation. So eventually, basically I use I power lah to see that if you add up all the terms on the right hand side, it becomes 0, and then you will get this nice equation that are labeled with 2 asterisks. And then it was just a matter of subtracting the other unnecessary terms to find gx lah. So this is the kind of thinking lah that you would need to demonstrate and execute in higher level subjects like history math. So you can see that this question was 8 marks, but then only this much working was needed. So I will contrast this to a further math question that came out for my year also. So this question is about conics again, and it's just purely purely on conics lah. There's no application to real world context or whatever stuff like that. So they give me the equation of a hyperbola, which is xy equals c squared. If you okay, I'll show you later if you don't know what a hyperbola looks like. Anyways, they just tell me that the normal to this uh graph at this point meets the curve again at another point, and then they ask me to find the coordinate of this point lah. So you can see on my working, that's what a hyperbola looks like. And actually, this question um can actually be solved using H2 math knowledge, or even um A math knowledge with like slight extension of differentiation, where and this slight extension is just called implicit differentiation, where you learn how to um differentiate this kind of uh equations like xy equals c squared. So if you have learned about it before, you would see that after this initial step of implicit differentiation, it was just a matter of finding the equation of the normal, and then um forming an equation for x, a quadratic equation for x, and then eventually just using algebra to solve this kind of um equation lah, to eventually find the coordinate of q. So in terms of the thinking for this question, it can actually be done by most of you guys lah. Let's say if I didn't give you the equation of a hyperbola, or I just give you a very typical parabola equation, you would probably be able to think of the solution, think of how to do it lah. However, the difference lies in the actual manipulation of terms. In AMath, in EMath, you probably won't be seeing so many different letters and seeing so little numbers in your workings. You're probably used to using numbers for your workings and um getting number results at the end of your working law. However, for the math, even H2 math I've seen before, is where you can just be purely algebra, because you are kind of working towards something called generalization, where instead of getting one result for a question, you can generalize the result to get the answer for the same question, but the question has different starting initial parameters lah. So like in this case, the variable here is c squared. So let's say if c is equals to 1, you just get a normal y equals 1 over x graph. However, if c is equals to like 5, it will be 25 over x lah. And then um the the answer for q will be different lah if I set the initial parameter to an actual number. So then for the second part, they asked me to prove this result. So this is kind of just in secondary school you would have learned this. It's called the distance theorem. So basically it's just Pythagoras finding the distance between 2 points and then proving that the sum or the distance of this line is equal to the sum of these lines. So it's just basically algebraic manipulation. But so what I mentioned just now is the difference lies in the level of the manipulation lah. You see all these kind of you'll be working with mostly letters instead of numbers lah, basically. So so that's basically what you can expect to see in A levels and what you can expect to be doing for the A levels lah. So now I'll be talking about um how do you decide between what math to take in JC? So for H1 math and H2 math, so like I said earlier, you can only take either one of these. And the decision making for these two subjects is quite simple, I would say. So for H1 math, it's if you didn't take A math in secondary school and if you don't want to take any more math in JC, right, you would probably minimally must take H1 math. I think there's only one school and only a few combinations where there's no math involved at all. And I think only, if I'm not wrong, ACJC offers such combination lah. All other schools, you must take at least H1 math, and it's usually taken by pure art students um who are probably not interested in math in the first place lah. So um there are some university courses where the requirement is just H1 math, and you don't need H2 math to get into that course lah. So for H2 math is kind of the opposite. So for let's say for university, you um let's say you have a goal in mind where you want to get this university course, and then you find out the prerequisite subjects needed for this course, and I would say most of them actually needs H2 math lah. So um especially for sciences like physics, chemistry, you probably need H2 math. And then so yeah, it's usually taken by science stream students and usually hybrid students as well. So yeah. So basically that's how you decide between taking these two subjects lah. But of course for H1 math, for us students, right, I'm not saying all our students will take H1 math, because there are people who take 4 H2 subjects as well. So their three main content subjects are the art subjects. However, the last subject is H2 math if they choose to take 4 H2s. So moving on to Photomath and H3 math, right? So okay, so for me, I chose Photomath kind of on a whim basically. So I mentioned just now, I didn't know anything about um, Photomath when I first stepped in JC. I only knew about the subject existing because I saw a sign that says there'll be a test for it later. I was like, oh, okay, that sounds interesting. So, but beforehand, I already had a passion for math, since like secondary school lah. So if you take further math, you're kind of also locking yourself out from certain university courses like medicine, um, those kind of biology or chemistry related subjects where you need to take H2 biology or H2 chemistry lah. So you should be taking H2 for the math if you are pretty much set on doing something math related for your university course. So for me, I was already set on doing math lah. So I chose to do for the math for JC. And also some topics in further math like linear algebra is actually very applicable to many math modules in university. So also from what I heard from my friends in university now, further math basically covers a substantial portion of first year university math. So it kind of gives you an advantage lah, I would say, because you are more or less prepared for the math portion of university for the first year at least. So for H3 math, you should take this subject if you really love math and you really want to um do math in the future lah, even for your job. So also if you are like a sadist like me and you like spending hours on questions trying to solve a question and then having the off chance of you not even solving it, then this subject's for you lah. So yeah, so so to talk about more about the how subject combinations work in JC, right? Um so like I mentioned just now, H2 for the math is counted as a content subject. So let's say the most typical subject combination in JC is PCME, physics, chemistry, mathematics, and econs. So um for me, since I was gonna take further math, I would have needed to replace either physics or chemistry. However, for my school, we if you take further math, you must take it with H2 physics. So uh the decision was quite obvious which one to replace. So I replaced H2 chemistry, and also um I also didn't want to take any chemistry related courses like medicine or whatever um chemical engineering in university lah. So it was kind of a easy decision for me as to which one to replace. Then for me, when I was deciding whether or not I should take history math in J2, I was kind of like I did decently for my promos, so yeah, it allowed me to apply for the subject in the first place. However, the main deciding factor was my interest, where my interests lie, and whether or not I was willing to put in the work and effort to study for a subject like history math. So this the this this decision making process, um if you are still stuck, you can kind of you can start with thinking about what you don't want to do first, and then you can slowly cancel out options lah. So you have less options to choose from, which will be easier on you. And then once you have that down, you can think about what you want to do in the future. If you don't have an answer for that now, it's okay. It's still early in your life. You're still secondary school, going to JC. So even for me, um, even though I said I was gonna take mathematics in NUS, right? I'm still thinking about whether or not I want to change my course in the future lah. So you still have time to think about it. However, if you choose to take further math, right, you're kind of like I said, you're gonna be locking yourself into courses like math, computer science, and engineering in university, and you have no leeway to take other courses in university lah. So that's a consideration for you to take. Someone asked, share some study tips. Okay, so for math, for me, what I did was, math is a pretty like easy subject to study for lah. So basically, once you um learn like a technique or a method to do a question, right, or learn something new in the topic, right, you will want to go ahead and do practice questions to see whether or not you really understand it. So let's say if you are making lapses in your working, you would want to consult your teacher to see how you can cover up or where to see where you're going wrong with your working lah. So um it's basically just a lot of practice, doing a lot of practice with the math and all that and all the papers, just doing a lot of papers. And it's a kind of a loop. If you don't know anything, you go ahead and ask your teacher, and if you then you go back and do your own practice and check back on yourself with like an answer key to see if you're going the right track lah. So yeah. So someone asked, what exactly do I mean by pure math? Okay, um so this goes outside the JC's context already. Math is actually broken up into two portions, pure mathematics and applied mathematics. So pure mathematics is usually has to do with the study of the subject itself, kind of like like what I talked about just now is like all the number theory, like talk about number theory and all that. Whereas for applied mathematics, it's something that can be applied to um real life lah. You can apply it to your daily life, and usually it's linked to like physics, engineering, and sometimes economics also. So like all those calculus, differentiation, integration, you can actually apply that to real life lah. But then there are some like differentiation and integration results that are for pure math itself, and then solving questions like rate of change of all this is it goes back to applied math. And then usually um in H2 math you will learn how to, so I think you've seen rate of change questions before lah, so you see the kind of questions again in H2 math lah.